We're going to use the information in this table. I'm trying to get my cursor. All right, and calculate the atomic mass, which is a weighted average of the isotopes. What that means is we're going to consider the percent or relative abundance of each isotope when factoring their average. So the way we're going to do that is we're going to take the mass of the first isotope, multiply it by its percent abundance, and we are going to add that to the mass of the second isotope times its percent abundance, and add that to the mass of the third isotope, multiply by its relative abundance, and you would keep doing that until for all the isotopes, and you add them all up and you get the atomic mass. So let's do it. The first isotope here, top to bottom, is oxygen 16, so the mass we're given there is 15.9949, and the percent abundance is, let's move that decimal over twice, turn that into a decimal because we are given percent. All right, so these are all percents. So that's going to be 0.9976, and let's add that to the second isotope is oxygen 17 with a mass of 16.9991. All right, times its, these are percent, so that still got to move that decimal over twice to make that a decimal form. So be careful there. That's 0.00004. And let's add that to the third isotope is oxygen 18, and that's going to have a mass of 17.9992. Multiply that by its percent abundance. This is a percent sign, so move that over twice. That's the same thing as dividing by 100. And that's going to be 0.0020. All right, let's get some more space. And now we can just punch the stuff in our calculator. I'm gonna do the step. I'm gonna break these down in the steps because it's gonna be easier for me to show you the sig figs when we get there. All right, 15.96. So this here is going to be 15.96 AMU. Right, I'm doing 4 digits because that has 4 digits and this has 6 digits. So our answer is restricted to 4. I know we're not done, but you can see that we're going to have to do another operation, a different operation, after we multiply all of these. So we're going to have to do sig fig rules after the multiplication step. All right, so let's do this one. We have one significant figure here. All right, so it's just going to be 0.00, but the important thing is where that significant figure is, because when we get to the addition part, it's not going to be about sig figs, it's going to be about placeholders. All right, so that's going to be 0.007 in the thousandths place, 0.007. Let's make sure there was, yep, they only gave us one sig fig. .007. All right, and again, that's restricted because this only has one sig fig and this has way more than one, so our answer can only have one. All right, finally, I think this is going to be a problem. My calculator is going to cover this up. So 17.9992. 17.9992. I think it was 0.002. I'm going to put that 0 in there just so I can see the sig figs on my calculator. All right, so that is going to be 0.0. All right, so what I'm saying is there's 2 sig figs in my percent, so I need 2 sig figs in my answer. So it's going to be 0.002. 0.036. 0.036. One more time. This has two significant figures. This has way more than two. That's a decimal, by the way. Sorry. So our answer has to have two sig figs. Now the whole point of this was to break it up into steps. Is when you're starting out problems like this, it's not so obvious. Now once you've done a few of these, then you don't have to do all of these in steps. You can just look at your calculator. I'll show you that too afterwards. When we're adding these up, I'm just going to line them all up by placeholders. Right? I'm going to bring this friend over there. So 0.007. Okay, and bring Amigo over there, over here, 0.036. All right, so they're all lined up. Running out of colors. So now when you're adding, because we've got to add them up all up at the end, you can see that our first measurement, this guy right there, is going to limit the precision of our answer. It never knew any of these, never knew it. So we can't have this stuff here. That's just nonsense. All right, so significant figure rules. So our answer has to have two decimal places, is what I'm saying. But we do need to know what goes here because that might round our last sig fig up. Okay, so 7 plus 6. Oh, you know what? You shouldn't use these numbers because these were all rounded. Oh boy. So look, all these are the better numbers. So we're gonna use that number plus, that's the better number, plus that number. All right, so these are the numbers you want to use. You get 15 point, and we know we need two digits, so it's going to be 16.00. 16.00. All right, so that's our final answer. And you probably already knew this because oxygen is such a common element, and you probably memorized it on the periodic table as being 15.999. So it's almost always just 16.00.